Hello students, welcome to SmartKidz tutorials. In the previous video we learned about voltage, that is potential difference. We also learned about current and how we measure current using an ammeter. Similarly, we measure the potential difference or the voltage using a voltmeter. We move forward, and before we move towards finding the resistance in circuit and what exactly is resistance, we will just go through a small recap, um, going through what is a electrical circuit, what are where is a voltmeter placed, where is a ammeter placed. Okay, let's begin with the electrical circuit. So if you have a look over here, this shows you a circuit diagram. Okay, and in this circuit diagram there is a 9 volt, that is potential difference across this circuit. There's a bulb over here, and there's a switch over here which when you switch it on, it gets connected, allowing the flow of electrons through the circuit, thereby connecting the circuit. So and this is skeletal framework of the circuit diagram, and this is what it would look to you in real life, wherein there would be a battery, okay, which would create the potential difference of 9 volts. You have a switch over here comparing with this switch compares with this switch. See, have a look. So that's off, and now it's on. See, off, on, off, on, off, there's no light here, on, there's light here. Okay, so when this switch is when it is switched on, then the circuit is complete over here, allowing the flow of electrons, and thereby current flows through the bulb, lighting the bulb over here. So this is how a circuit diagram would look like. For you it would look like this in your day-to-day life when there is a switch. So if you, in case of the appliance can be different appliances. It could be a bulb, it could be a fan, it could be a television set, it could be a music set, whatever. And there would be something creating a potential difference across the circuit uh, to allow electrons to flow from one end to another. And when electrons flow from one end to another, the electricity or current flows through that particular circuit. This is how it would look like. Here, okay, so this is if you have a look over here, there's a battery that is put over here for potential difference. This is the switch, and here's the bulb. So the bulb will light only when the switch is on. When the switch is on, you see these blue dots, these are actually the electrons. Once again, we'll have a look. The battery is put over here. Here's the switch in off mode, and the bulb is put. So when we switch on, the circuit is complete, allowing the flow of electrons, and thereby the electricity or the current flows through this particular circuit, lighting the bulb. See, this is the same as what we saw over here in the left hand side. Next, to the electron flow. We discuss about the flow of electrons. The flow of electrons is opposite to the flow of electrical current. In this case, we are shown that the electrons are flowing in this direction, that is the anti-clockwise direction, which means that the electricity will flow from positive to negative, whereas the electrons flow from negative to positive, because the electrons are negative in nature. They have a negative charge. So you see, the electrons are only flowing when this switch is on, which means it completes the circuit. Okay, see, the electrons need to flow smoothly, and for that to happen, the circuit needs to be complete. This switch acts like a brake. So when we switch it off, we break the circuit. When we switch it on, we complete the circuit allowing the flow of electrons, and hence the current flows through the circuit, lighting the bulb. Coming to the ammeter and voltmeter. So we spoke about ammeter measuring the current flowing through a circuit. So here it shows you that this is a circuit, and the circuit is connected to a bulb, and it is the ammeter is also connected in series to the circuit. Yeah, so when when the wire is connected out here in series, there is a flow of electron, the flow of current, which is measured by this ammeter, and you will see this. There is a deflection in the needle. The deflection in the needle will shows you that there is a certain amount of current flowing through this circuit. We know there is a current flowing through the circuit because this bulb comes on. Okay, but how much is the current flowing through the circuit, that only an ammeter will be able to tell you, and that is when we connect the ammeter in series in the circuit. Have a look. So this is how an ammeter is connected and how it measures the current flowing through this particular circuit. Okay. Then you have the voltmeter. Here you have 9 voltage battery, and the bulb is on over here. This is the supposed to be the voltmeter, okay, measuring the potential difference across, and it is connected in parallel to the particular bulb. See over here, see the difference between this and this. Here, if you notice, the ammeter is right above the bulb, whereas in case of the ammeter, it is not above the bulb, but it is in line with the bulb. That is why it is in series, whereas this is parallel to the bulb, as a result of which it is connected parallel in the series, the voltmeter. Okay, have a look. So whenever there is a voltage, now in this case there is a voltage of 9 volts. Volts are the units of voltage or potential difference, and amps are the units. Here you can't see the amps, it only shows a big A symbol showing that it is an ammeter, whereas here also we can't see whether it's V written over there, but what we can see is when the voltmeter gets connected to the circuit in parallel, the needle gets deflected towards 9. Okay, that tells you that the voltage as shown over here is 9 volts across this particular segment. See, from 3 or from actually it is from 0, it moved to 9. So that shows that this particular circuit has a potential difference or a voltage of 9 volts across the circuit. Coming to the electrical circuit symbols, so you'll find the symbols at various places on electrical circuit boards as well, but from your exam point of view, when we draw a circuit diagram, so these are the symbols that we use to indicate or symbolize that particular electrical component. So if it is an electrical cell, then this is how it should look like. Okay, plus and minus indicating the charges. Okay, the big line over here will have the plus sign, and a small line will have the negative sign. Here this is an electrical battery, and see how it looks in comparison to the electrical cell. See, once again positive and negative, and then you have the bulb. This is how we indicate the bulb in a circuit diagram, or we could even put it this way. One of the two ways is fine. Further on, a plug key or an open switch is indicated this way. This is a closed one. A closed one means that the circuit is complete, which means the switch is actually on. Here is a joint in the wire. Okay, so if there is a if there are more connections to the circuit, this will how it will look, like a T joint, upside down T. If there is no joint, but there is a wire crossing above that another wire, then it should be symbolized something like this. We'll come to resistor. A resistor is symbolized this way. Then we have a variable resistor or rheostat. We'll learn about this in the coming slides. Ammeter is indicated this way, plus and minus. Voltmeter is plus and minus, like this. Coming to the Ohm's law. Okay. What does the Ohm's law state? Ohm's law states that under no same temperature, electric current flowing through an ideal conductor is directly proportional to the potential difference across its end. So this is what it indicates, that the voltage or the potential difference across the circuit is directly proportional to the current flowing across the circuit. And we remove the proportionality sign using a proportionality constant, which is R, and R over here is resistance. Resistance is a property of the conductor to resist the flow of charge through it. So depending on the conductor, okay, each conductor, that means we are talking about a metal, will have some amount of resistance to the flow of current. Now that depends from the metal conductor, one metal conductor to another. Depends on certain other conditions as well. Resistance, but we need to know, is a property of the conductor to resist the flow of charge, flow of electrons through the circuit. And the SI unit of resistance is ohm. This is how we give it. R is equal to V upon I. Same this thing. Here it's V equal to I R. The way I remember it is the name Vir. So VIR. So then you depending on what quantity or what are you looking for, whether you're looking for voltage, current or resistance, three quantities can be found out using this particular formula. You can keep changing it. So if you want to find voltage, then this would be the formula, direct formula, V is equal to IR. But if you need to find current using, if you have given two other values of voltage and resistance, then it would be I equal to V upon R. But if resistance is something that you need to find out, then it would be V upon I, the one shown over here, okay, which is 1 volt upon 1 amp. That would be also its definition. So that means the resistance of 1 ohm is nothing but 1 volt of potential difference across the circuit when 1 amp of current is flowing through that particular circuit. Okay, so I is equal to V upon R denotes that current is inversely proportional to resistance. In other words, in simple words, it means that when current increases, there is less resistance. If there is more resistance, the current will decrease. So they work in opposite fashion. So when the current increases, it tells you that the resistance is very low. But if the resistance is very high, that means the current will be fairly less that is flowing through that particular service. Whereas in contrast to that, uh, voltage is directly proportional to the current flowing through. So if the voltage increases, the current will also increase in that particular circuit, because we know that voltage is nothing but it's an electrical pressure at the two ends of the circuit, and it's the work basically the work that is needs to be done to bring the electron charge from one end to another end. Okay. Rheostat. Rheostat, or we call it as a variable resistor, is a device or component which allows changing of resistance in a circuit, keeping the voltage the same. So without affecting the voltage, we can change the resistance using a rheostat, or we also call it as a variable resistor. So in a conductor, electrons are attracted by the atoms. This is a resistive force which is lower for a good conductor, obviously, and very high for an insulator. Insulator, we usually use insulators to protect from high voltage, to protect from spikes of electricity. Sometimes we have huge spikes of electricity which can damage electrical appliances. So for that we need some sort of insulation to maintain a particular level of electrical current flowing through that circuit. So a conductor having some resistance is called a resistor. There is an Ohm's law experiment. By the way, the Ohm's law was actually found by German scientist called Ohm, and an experiment was conducted to confirm how resistance keeps changing, how it is um, related to voltage and to current. Okay, so here you see there are three electrical circuits that you see, 1, 2 and 3, and for the same resistance R. Okay, the resistance across all three electrical circuits is the same, but it is at a three different voltages. Okay, so the resulting potential difference will always be proportional to the current flowing through. So the voltage, which means that the voltage flowing through this across this three circuits will be equal to the current flowing through these circuits. That is what it means. So factors on which resistance depends. Okay, coming to the resistance of a conductor depends on the length of the conductor. It depends on the cross section area. So that means when you cut it, how much is the cross section area, and on the nature of the conductor, of the material of the conductor. Okay, what metal it is, whether it is allows more flow of currents or less flow of currents. Okay, so resistance of uniform metallic conductor is directly proportional to its length and inversely proportional to the area of cross section. Let's look at the formula. So it says resistance of a conductor is directly proportional to the length of the conductor. So how long that? So longer the conductor, more will be the resistance. Okay, because it will encounter more atoms. We know that electrons are attracted towards atoms, and that will resist the flow of electrons through that particular circuit, and less current will flow through. Here you go, and it is inversely proportional to the cross section. The A does not stand for ampere, it stands for the area, cross sectional area. So when you cut the wire, how much is the cross sectional area? So have a look. Okay, okay, and this to remove the proportionality constant, proportional sign, we have a proportionality constant called rho, which is known as constant of proportionality over here. Yeah, this is a graph that actually shows you the graphical form how the when the potential difference increases, current also increases, and we get a straight line if we plot for the resistance. So you see, it's an exponential value that we have for resistance, but it's a very straight line, and we can have several points plotted if we compare the potential difference and the current in this case. So it's a linear increase in current with increase in potential difference. Electrical resistivity. So rho is called as the electrical resistivity, which we also known as the proportionality constant. Is the electrical resistivity of the material of the conductor. Okay, so what that conductor is made up of, the material. SI unit is ohm meter. See, SI unit of resistance is ohm, but SI unit of SI means standard international. SI unit of electrical resistivity is ohm meter. Resistivity of conductors is very low, whereas insulators have a very high resistivity. Of course, they're supposed to insulate from high current, okay, flow of electrons, and the resistivity varies with temperature. So uh, with temperature, the resistivity will increase or decrease. Alloys have higher resistivity than metals, okay, and that is why used in uh, electrical heating devices like iron and toasters. Tungsten is used in the filament of electric bulbs, okay, and that's the fine filament that you can see in the bulb. And aluminium are used for electrical transmission lines, okay. And here you have some of the conductors, alloys and insulators, and this would be their charges, okay, right. So we stop over here. And if you like watching this video, please hit the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive updates. Thanks for watching. See you in the next video.